So it is time to get started. So this is our final review period for the final that will take place on Tuesday. I got a request from Daniel yesterday that he wanted some LLK practice. But since he's not here yet, and I assume he wants the answers to those, I can start with whatever questions you have and we can go from there.
Yeah, I was kind of hoping we could review the idea of a bottom up versus top down parsing of a
Yeah.
parse tree.
Yeah, so the difference is that in top down, we're going to start with the start non-terminal and try to derive the string starting with the start non-terminal. So we'll kind of go from left to right and try to match. It's exactly what LL parsing is trying to do. It's going to try to match non-terminals with right-hand sides of productions to try to create the structure of that. Now, how do we do that in general? Both CYK tackle it that way and LL tackles it that way. LL just happens to be more efficient. And then bottom up is the LR version where we're taking the string and we're trying to now find places to reduce parts of the string down into non-terminals. So we're going the opposite way. We're looking for right-hand sides and replacing them with non-terminals in the string, trying to derive just the start non-terminal.
Okay. That definitely helps a little bit.
You can draw out some examples that would help as well.
It is a simple one that we can go through that shouldn't be too bad.
Yeah, so let's come up with some kind of interesting, simpler grammar than either of these. Let's say. Yeah, we've done the lovely ASB a lot, haven't we? Okay, what is the A just happens to terminate us. What's a string in this language defined by this grammar?
Just A.
That is true. Something slightly more complicated, so there's a little bit more of a path through it for us to see.
B.
Yeah, that works. So in top-down parsing, we're going to, or a parse tree, we're going to start with S and say, all right, which one of these productions do we apply to match this idea? And that turned out to be a little bit more complicated than I might have intended. But with AA, there's only a way to make an AA or an A out of this. We can't get that B anywhere in this sequence of productions. So that tells us that if this is going to be a member of this language, then we must first apply this. So we are now going to start to make our parse tree. We have our terminal A, we have our non-terminal S, and we have our terminal B. So now we need to expand this S to see if we're going to do this. So now, since this would force there to be a second B, there's not a second B in there. Yeah, we need to use the AA rule if we're going to have any hope of seeing this. And now we have, via a depth first search, AAB. So, okay, that works. So we just turn this A into lambda, and we're done. And if we wanted to formalize this process more, we could build a CYK table. We could go through the actual LL process of calculating first of S, first of A, follow of S, follow of A, build the LL1 parse table, see that there's a conflict, see that it's an LL2 grammar. Is it LL2? It's LL3. This was a good example. Well, the reason is that you can repeatedly apply this S to S rule and get AA, and you can repeatedly apply this and get AA. So we need that third symbol past that in order to be able to distinguish. Because this is a B, we know that it had to be paired with this A, basically. Which meant that we needed the other production to produce this middle A. So this was just kind of a logical version of this. This is what I expect some people to do on an exam, rather than go through an actual process unless the question asks for that process. So this would be an example of a top-down parse tree. So now, the bottom up, we're going to start with the string itself. We're going to start with A, B. And now we need to find a way to kind of go the opposite way. So what happens? We can get an A from nothing. So we are going to just make an A that came from nothing.
We do that kind of a land.
Right. Because A can just go away. So now we bring down this A and we see that there's an AA right there that we can combine to make, sorry, this A becomes an A. That's even easier. We don't need the lambda here. This became useless. We're going to turn this A into an A, which is the reverse of that rule. And now we see that we have a AB. So you see how we didn't do that here. This AA became this S. So we don't want to do that because we never did it on this side. So we can, in fact, make an A out of nothing. Turn this A, see that this A exists. AA is an S. We're going to bring this down. AA becomes an S. And then we have ASB. So now we're going to bring this down, and this down, and this becomes an S. And since we were able to derive now the depth first search from this all becomes the S, we kind of have a bottom-up parse where we started with the string and we tried to do a replacement of each side of that to produce the start terminal.
Yeah.
So top down, start with the S, derive a depth first search that is the string. Bottom up, start with the string and do replacements in that, and then eventually just derive the start terminal. So I'm answering a question on top down versus bottom up parsing. This was a grammar that I drew as an example, and we did a simple string, top down and bottom up. And I have two examples from your question from yesterday, so we can do that at any point. Just wanted to wait till you were here.
Almost died like fuck, so I'm trying to get you.
Right. My car was parked on one of the steepest slopes on South Hill. And it was just a sheet of ice. So I'm just sitting there like, all right,
Yeah, like the whole
how do
entire,
I get across to my car?
Yeah.
the whole entire bridge is like a sheet of ice.
Yeah.
Like, yeah, I've never walked so slow in my life.
Yeah, it's a treacherous morning here in the Northwest. All right, any other questions from you, Logan? What can I address?
This is just something I saw on the review for the final is what is bytecode?
Bytecode is what Java gets compiled into.
Okay.
Some other languages as well. It's a separate middle ground between that and assembly. Rather than Java being compiled into assembly, it goes into Java bytecode.
Okay.
And then we have a bunch of different processes that convert that bytecode into machine instructions across all the different platforms. And that's what makes Java so platform independent, is that regardless of the system you are writing Java on, we can use that same compiler to compile it into the bytecode. And all that changes is the interpretation of the bytecode based on your hardware. Okay.
We've heard of the parsing is the membership problem, right?
Yeah, so we need to figure out if a program is part of that programming language, the syntax question, it's the membership question. Is this program written in this language? Is it a legal program? Is it a legal sequence of instructions defined by the rules of this language? Before we try to run a bunch of instructions, we need to convert them into instructions. Before we convert them into instructions, we need to know whether it's possible to convert them into instructions. So the question of, is it possible to convert this into a sequence of instructions that can be run on this hardware? Answering that question is the parsing problem.
How would you determine something is undecidable?
So something's decidable if we can answer yes or no to it. So something that is undecidable, we cannot answer yes or no to. So what would be an example of an undecidable problem that we've covered in class?
The CYK that can loop forever if it doesn't have a certain condition that lets it exit.
Potentially, the one that comes to mind for me is like list all real numbers between 0 and 1. That is undecidable because we can't answer yes or no to it. But anything that we could answer yes but not no to is also undecidable in that. We don't have the ability to decide yes or no. So yeah, that's decidability from the computer science perspective.
No, well, hold on, pretty much.
All right, so I guess we can switch focus to LLK. I have a couple grammars for you. The question is, these grammars are LLK for what value of K?
Well, one first time.
Yeah, let's start with the left one. Just decided to write them both up there because I had a little bit of time before class started. Have an answer?
Three for the first one.
3 for the first one? A good guess. 4. Also a good guess. I'll give you a hint. One of the two of you is correct. The definition of LLK, the K means that we can distinguish between at any set of productions. If we have a look ahead of that many characters. So if we have a look ahead of exactly 3 characters, can we distinguish any set of productions? If we have a look ahead of exactly 4 characters, can we distinguish any set of productions? So I'm telling you now that the answer to is it 4 is yes, we can distinguish with 4. The question is just, can we distinguish with 3? Did I convince you otherwise?
Maybe a little bit,
It's unfortunate because you were right the first time.
BCB in from the S production.
Yes, that is what does it.
but- Okay,
Yep. So this is an LL4 grammar. And the reason is exactly as Logan pointed out, we could end up producing this exact BCB starting with S. How do we do it?
we can go from the B to BC.
I actually think we want to go from. Because otherwise there's no way to make the Bs that we need, so I think we need to go. BB, and then I think we do it again. We make B, BB, and then we turn this B into BC. And now we see that there's the BCB, but it's that 4th character here that tells us whether it's the end of the string or whether we can produce a B. And that's before we even move on to the A, because the A could be an A, so if this is an A, then we didn't produce this twice, we did this once. And if that A becomes a lambda, then that also could have been that to the C. So that's the reason behind it, but we should probably start to be absolutely sure of this whole process. Start with how many characters do we need to distinguish between each of these subsets of characters. So with C, there's only 1 production. So that's of course LL1 because you always use that production. With B, we have to look now to see this B it will eventually be this. So this is LL2 because no matter how many times we do this, the first character has to be a B. But what comes after that is going to dictate which of these was used first. So we're either going to see BC something else, or we're going to see BC B. And if we see that B here, then we know that this was the first production that was used.
Will there be 2 look aheads or 3 then?
2.
Okay.
Then for A, we can distinguish with a single character. Either it's nothing or it's A. So we have 1, 2, 1. Now we get to that S. So for the B, we need 2 to figure out which of these was used. And then you can see that it actually becomes 4 if you add this up. I'm not sure if that's reasonable, but you can see from this logic that we need the two characters to figure out that which of these productions was applied, and then it scales down from exactly that to this problem, which allows you to see that it is 4, since none of these were higher than 4. The fact that this was 4 is going to tell you that it's the dominant term in it. But to be sure of that, we did have to go through this work and make sure none of these numbers were greater than 4. Questions on that?
You don't really have to go through all of the first and follow in order to see that, do you?
Nope.
Okay.
Not logically. If you're running a program to do it, you need to figure that out somehow. And you would have to go through first follow, build the table, see that there's a conflict, try to build the LO2 table, see that there's a conflict, build the LO3 table, see that there's a conflict. That's why I don't assign that. That's an annoying amount of work for the last week of the class.
I appreciate it.
So let's try the one on the right. This is LLK for what value of K? What do you get?
I said it's not an LOK.
Okay, Sam, this is not LLK. What leads you to believe that?
Okay,
The fact that, yeah, from this A, we can generate in here or here an infinite number of A's. So we would never be able to determine between these two productions.
And then also even that S, you start with either an A
Or
or
an A or an AA. Yeah,
it's
we,
always gonna lead to that.
yep, that is correct. So this is not LLK for any K. Usually those are a little bit easier to identify, so this is the easier problem because of exactly that. You start to see that infinite recursion in multiple places, the same infinite recursion. You go, wait, I'm never going to be able to determine which of these productions to apply, which means that if I tried to write out a table, there would always be a conflict between those right-hand sides. They would always be together. In the row, capital A, column, lowercase a, you would always have these two options, regardless of the look ahead. All right, most of the couple that I prepared, one to identify a larger than LL2 grammar, and also one that was not LLK, just in case that shows up. What else can I go?
I had a question on the homework, but I forgot it, so.
I could certainly help with that if you can remember it in the next
Yeah,
few minutes.
I got to a certain point and then I questioned, so I went to bed and I forgot it.
It's amazing how that works, right? It's just like restarting a computer. So what was in RAM? What was in RAM, computer? It's like, I don't know, I wiped that. Crazy how just the ability to relate what it is that we're doing, like, here's RAM, there's the page file. You're writing it down so that you can load it back into RAM later. We're just little machines, just little computers. Significantly less powerful, but with better parallelization.
Probably also help if I had brought my homework.
We would, with the questions about.
That's the thing, you know, it's from the first half of it.
This is the word we use for program by chance. Yeah, what would we divide in the program? The way you're considering.
Oh, it didn't slow down, sorry. Oh yeah, the first. Shooting the like first of like AA, capital A, B, B. Or whatever.
Where, let's,
I guess like not that example specifically.
we can even go through that example.
Okay.
I don't care too much, as long as it leads to learning.
It's one of those, I get it if it's like just first A or first S,
Yeah,
but
so what's the grammar?
S produces A S lowercase a. Yeah, SB. Or lowercase a, uppercase A, B. A produces A lowercase a, uppercase a. And then lambda.
Okay. So calculating first of anything
Uh,
in here?
A lowercase, or two lowercase a, uppercase a, and then BB is the
Lowercase a. Wait.
uppercase a is after that, and then BB. First of that.
So, yeah. So the first of this, since the first character is a terminal, is just A.
So is it pretty much just first of capital A then?
The first of this whole thing is just lowercase a.
That's it?
Because, yeah, it's the only way to produce, you have this string, if you have the first of this, then what is the first terminal that could appear in this partially derived string?
Not that stupid.
Is that.
Okay, so it's a lot more simple than what I was thinking.
Yeah, what's nice about this whole thing is the first of everything has to be an A. Follows where you can get B's, but the first of an S or the first of an A has to be an A. Well, unless A derives lambda, in which case it's not really a first though. The first of that is lambda. Because the B is what follows it. So yeah, the first of A is A and lambda. The first of S is just A. Then follow of A is going to be B That's it. And follow this is dollar or B. And that's it.
Well, I haven't verified myself, that's all I got.
It's a good thing to have clarity on,
Yeah,
otherwise lead you down a strange rabbit hole. What else? Any issues with homeworks? How are the labs going?
Pretty good. I'm a little stuck on just the output for my LL parsing. But that's, yeah, that shouldn't be too bad. I'll figure that out at some point today.
I was gonna take a look at that today and see how far I get on it.
It's a fun one.
Would it help if I gave people until tomorrow on just exactly that lab?
That would help me a little bit, actually. I have to work later today, so that would.
Yeah, I had one student request that who isn't here, and I was trying to figure out what I could do with that, but if it helps multiple people, and I think our grader has enough with the homework in the other lab that I could push one of the labs by a day without affecting the grading timeline. I'm a bit concerned with him because he has about him, he just has a lot of work to do over the next week for me. So I'm trying to make sure that he has a workflow that isn't held up by grading.
Oh, yeah, I definitely will advocate for that. If you want to extend it back a day on that one.
Yeah, I think I can do that. I'll go make that announcement. And hopefully that allows Daniel to get it in. I'm gonna finish it up.
Probably procrastinate, if that will happen.
Yeah. What happens, happens.
Yeah. Oh yeah, no, I did figure out the CYK lookup thing.
Good.
Don't know if it what you're supposed to do, but flipped the whole thing pretty much.
Yeah,
So is anything that produces, or yeah, anything that produces AB is on the right side of them.
yeah. You can certainly do it that way. Other questions? We feel ready for a final on Tuesday?
Feeling pretty confident, honestly, yeah.
It's unfortunately at 8. I hate that.
It's at 8. Oh, I missed that.
Yeah.
That'd be fun.
I'm not a morning person. If that wasn't
I
obvious.
can be if I'm set up for that. And I mean, I have been for teaching, but yeah, if I get in the habit of waking up a bit later, having a single day where you wake up earlier is difficult. The key is to wake up at 6 every day, and then it stops feeling weird.
My issue is I stay up too late right now, I'm doing my homework and stuff, and so then I get like an hour or two of sleep. It's like,
Oh, no. That does not work.
Yeah.
Yeah, the times I put myself in that situation, I just realized that I'm working on about 20% capacity. And what would normally take me 1 hour takes me 5 hours under that.
Yeah.
So it's better to just take a short-term hit, get the sleep, tackle something hard the next day, and you make a lot of progress on it and catch back up. And it all starts with procrastination. So as soon as you realize that, oh, I'll just do this a little bit later, as soon as you can catch yourself thinking that, just go, you know, what led me down this rabbit hole last time was thinking that.
Oh, yeah.
But they still keep doing it.
Right? That's what we need gamification for. That's what my entire research platform is. It's motivating, giving people a reason to not do that. Aside from, you know, your future well-being. But hey, if it means progress in a game, then people will take it seriously.
Oh, yeah.
Especially if it's a game that you're competing with others in the same class doing. Or cooperating with, and you wanna have the strongest character for those cooperative. Basically, I turned the concept of a microtransaction from costing money to costing effort. And if people can get in assignments early, that gives you a little bit of a nudge on that effort side. So if you could turn it in right at the deadline, or you could turn it in a little bit earlier and get the same grade, now you're motivated to get the work done early, get it in early so that you can get that microtransaction benefit in the game that you're playing in the whole class.
I like that concept, it's pretty good.
Yeah, you can tell what motivates me, rather than go make this a monetary. Predatory monetary thing, I'm thinking, how can I motivate my students with this? Anything else? I guess we can call it. All right, I'll see you all on Tuesday.